Okay, and we're running on live stream. And let's make the announcement. It's the 85th Knowledge Seekers Workshop of the Keshe Foundation Spaceship Institute.
Excuse me.
It's October 29th, 2015, and we're in the middle or toward the end of the week with these power systems and the teaching for the blueprint this week. And today we'll have some presentations from some people that are working on those systems, as well as other teachings from Mr. Keshe. So I think we're ready to go there. Go ahead, Mr. Keshe.
Good morning, good evening, good day to you, as usual, wherever and whenever you listen to this presentation. Today is part of the Blueprint Day and part of the workshops, normal Thursday morning workshops, which has been done for nearly over a year and a half. Today we try to see what's the next step to complete the blueprint. There is people who have already produced some things and they have made the rings. I have to tell you and warn you to make sure that your rings are fully nano-coated and fully put into GANS material and dried properly. If you don't have a full cover GANS on your rings, you'll find out your system will not operate. So if you are not sure, put the system through the GANS liquid for a second time to make sure it's fully covered, because without it, the nanolayers do not interact. The next step of the development of the blueprint to be able to add the system into or connect it to the main is that if you connect your system, which you have already done, the 3 stacks.
I'm on the Knowledge Seekers Workshop live stream. Well, there's probably no, because there's thousands of people on the Knowledge Seekers Workshop. Because that's the one I've already announced, I believe. So I'll make an announcement on the other site there. We'll try to redirect them. Thanks, Vince.
So what we've seen, what we said, your system at the moment should be on 3 stacks. What you did, or what you should have done by now, you should have had your central rings and you had your outer rings. Doesn't want to undo. Okay, doesn't matter. Okay, so you have your second ring, and what you should have done by now, you should have connected somewhere here from your central gravitational, and you would have had a line out on the top end, where this would have been the negative, or in a way input to the tower, and this would have been what goes out of the tower. You connected the positive end of this to the negative end of that, and positive end of this to the negative point of that, and you should have got something like this out. Now you have a unit like this, but to be able to connect it to a power supply, we have a lot of ladies talking here. when they come, it's a coup d'etat outside. So we have to carry on in a way that this unit can be added to power supply from one end and can be connected to the load on the other end. To connect the stacker to be in correct condition, you need to add your system in two new ways. And you need a connection to your power supply. If you connect as it is, your response power will not be that good, and the power supply can be erratic. So what you need to do is to add 2 units into the system. 1 unit here across the 3 plates, and 1 unit across the load or power supply. These units, what we call plasma capacitors, are essential. Otherwise, you will not create the condition to filter the system into plasma as you need it. So what you need to do, you need at a point where you connect your line or of the gravitational point of the first plate and the magnetical point of the last plate, you need to put 4 plasma capacitors in parallel with the load. This allows you to push the power and get synchronicity out of the set. You need the same set of 5 plasma capacitors in parallel with the power supply too. This way, the system responds totally on a balanced state. You need 5, or here in the power units which we deliver, you have 4. But 5 is much more practical. It's much easier to handle the power supply. So you made a stacker. Now you need to make yourself 8 or 9 capacitors, plasma capacitors. In Philippines, they are using conventional capacitors in that series. In Italy, we have used plasma capacitors. How you make a plasma capacitor is extremely easy. What you do, you take one of those nano bars which you made. You take a fire resistance paper. Fire resistance paper for you can do at home is the papers you use for baking, which you put at the bottom of the oven that they don't burn. You take the paste which we asked you to keep, and all you do, there are videos of this on the internet, how to make capacitors. So all you do, you add a small amount of the GaNs in a paste, and all you do is rotate it or put it anti-clockwise. It's important to understand anti-clockwise into the paper. Then you seal it. What you need to do now is to produce, if you have done it, to make small coils which are tight enough that what you can do, again, anti-clockwise, you have to look in the direction of the position, and you put the tissue paper with a capacitor inside. This is a simple plasma capacitor you make, and you secure it and tighten it with insulation. This has to be insulated. So what you do, this should be totally tight, so you increase the tissue papers, and it has to be secured that it stays in position. This, what you put in, the simple wire, this is your negative point, your entry, and the other side of the coil is your exit. The way you position is the single piece wire gets connected to the line in parallel with each other. So what you'll have is 4 of these sitting in line with each other, and you connect all the negatives together, all the positives together using the wires you had, which you nano coated, and you connect them as one unit to the live line of your wire. If you make these 2 units, these 2 stacked units of parallel capacitors, you make another 4 for here on the same position, negative and positive to the line. So now what you need to do to build these capacitor units. These capacitor units are the key into being able to transfer the AC into a plasma capacitor into plasma conditioned power. The units which were given to the government carries only 1 capacitor, and they could be dried up, but if we can replace it, or a unit will be sent to them. Because we've seen problem with a couple of them that they dried up in production. So the units are working, but they don't perform the way they should do. That's what happens. If you don't get a power unit out of your units when you receive it, this is the only point that the capacitors could be not working. But in the production, it has been looked after that this doesn't happen. So you have a very straightforward system with capacitors. So when you look, this is your wire, the simple wire. You added what you call the GANs. You covered it with a tissue paper of fire resistance, and then you added anti-clockwise. It's to do with my ring. Then you added an anti-clockwise coil on it. This is the negative point. This is the positive point. You put it in parallel with a line of power. I explained to you. Once you made it and it's in that set, what you're going to have is that's the coil, and you need 4 of them. Or 5 of them, and this was your center line, the single wire which came in. You connect the wires together This way, you connect these four together and you get a line from it. So now you made four parallel. This stays your negative, and this stays your positive. So this is what sits there or sits there. Then the final stage, when you made your parallel sets, is connecting the final piece. The final piece will look like this. You have your stacker unit with the three stacker on it. The wire has come out there, and you have a wire here. This is the end of this cable where you plug in. Your plug-in, your wire to the power has a neutral and a live line. So what you do, you cut into the live line, you connect the negative of the system to it here. So what it is, your connection, the interface is on your live to the negative. Your capacitor has been set here. The capacitor set of the four sits along here. You have put a capacitor set here. You have put a capacitor. You have put a capacitor. What's happening? It's jumping. You have put a capacitor set along here. You connect, then your load to here. This is this wire. This wire which comes to the plug gets connected here. And your other wire gets connected back here. So this is your full set power unit. You connect this to a plug into the load, into the power supply, and this is your load. This is your power supply, and this is your load. This is a total structure for a power supply. This is the total blueprint. As I said, by today, we complete it. And if you have managed to complete this, you should be able to connect. Make sure there is no moisture in your capacitor. It's dry enough, otherwise you get the sparks. And you can connect it to the load. What we've done, we have added a thermometer measurement system somewhere here, where if the